Hey there, welcome to episode 118 of the Quaggling Sand audio program. I am your host, Dan Hugo. We are recording this at 8:41 a.m. Pacific Standard Time here in Greater Vegas on Wednesday, February 11th, 2026. We normally publish Quaggling Sand on Wednesdays, often in the morning, sometimes not. So we're doing well so far. If you've never heard of or listened to an episode of Quaggling Sand, or what quaggling sand is. First of all, I'll tell you right now, it's a technical term that I coined when I was very young. You probably refer to it more kind of the normal lexicon as pins and needles. Quaggling sand, the return of sensation to, it could be a hand or a foot, a head, when circulation has been cut off for some amount of time. It goes numb. And so similarly, Quaggling Sand, the audio program, is a recollection of days gone by, tales, stories, missives, a little bit of everything. It's totally self-serving, but who knows? Maybe it's interesting. Maybe you'll find something useful. If at the very least, I will run out of stories at some point, so you have that to look forward to. In the meantime, it's good for me to reflect on some things and to try to tell them in a positive light. So that for myself, I have something to look back on when I'm no longer able to stand, speak, think. I can just listen to myself, and it'll be like me talking to myself. On all those notes, hopefully, wherever you found this audio program, you'll be able to locate the episode description, which contains the show notes, including a brief summary of one sentence, which I will read to you. The two usual audio program links, nothing new for today. I was thinking I could link to like what process and workflow are and whatnot, but this is my story. I don't need to. You can look those things up if you want. Maybe you're a process engineer. Maybe you're a chemie. Maybe you do system architectures, network architectures especially. So maybe you already know. Totally fine. So yeah, let's get started so we can get finished and publish this on this Wednesday morning. Summary of today's episode. I have always been fascinated by the way things work in a stream, mostly. And while I am no expert, I think I see them as though I am. Ooh. Quagglingsand.com. That's Quoggling. Quaggling, of course. That's the usual spelling. Sand, S-A-N-D, all one word, no spaces.com. The homepage. Eventually, I will reach the primary point of publication notion with a visibly appealing website. But right now it is, you'll find links to where to find episodes at the moment. I will say right now, I'm working on at least one other website that needs to be, I have a simple version up, but we need to roll out some signups and some other things and some resources and whatnot. So as I've said a couple times, I just have a lot of things and all of them are similar. So, I can do some over here, but I can do the same exact things over there. It's priorities. The profile page linking everything. buymeacoffee.com/DanHugo. You'll find links to all of my audio programs, where to find them, various projects I'm working on. It reminds me I gotta update this with the Smart City Vegas project, a challenge, the Smarter Smart City Challenge, which we are putting together right now. It will last through 2026. Into 2027, in fact. You will find some affiliate links there. You do not need to spend any money. You don't need to buy me a coffee if you don't want to. There's no reason to. I have plenty of coffee right here. But if you do happen to spend money in any way, or if you use any of the affiliate links, and I find myself having to deal with millions of dollars of inflows as a result, I will spend each and every dollar that makes it to me through the buymeacoffee.com/DanHugo page or platform, I guess. All of that money will go towards the purchase of coffee accessories, and so on. That's how that works. So yeah, let's get started. So factories. When I was younger, I used to like to watch the old Saturday morning cartoon lineup, and especially part of that, somewhere in there, was an occasional factory scene in a cartoon. Some sort of mechanization, maybe some Powerhouse riffs. Powerhouse by Raymond Scott, the dun 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 dun. Yeah, there you go. That's why I'm not a beatboxer. These were always interesting to me. So Growing up, there was always an opportunity to be involved in small processes at home, like making dinner or baking cookies around the holidays, or laundry, short workflows that could be, they're still educational in those early days, right? You learn how to piece together skills that you have and understanding how things relate spatially and temporally, right? Just something as simple as putting the clothing into the washing machine, sorting it by colors or however you do yours, waiting for it to come out of the washing machine after you've added detergents and so on, putting it in the dryer. Like all of that is a workflow. It seems very simple now. You do it all the time, right? But it's one of those, it's an early educational moment. Dishwashers or even washing dishes manually. That's always fun. Did a lot of that at McDonald's. So yeah, baking cookies especially, which I'll touch on the cookies again in a moment. Over time, I think we all encounter scenarios in personal pursuits, in a workplace, or maybe it's part of some entrepreneurial adventure where trimming down a process or tuning up a workflow can make it easier, cheaper, faster, maybe all of those and more. So it's a reasonably useful skill or talent, maybe, to be able to sort of get a handle on what's supposed to be happening, what's actually happening, how we can make it faster, better, cheaper, all that stuff. Oops, hit my fingers on my desk. Ouch. So cookies, as promised, I mentioned cookies, and we used to make them in reasonable quantities in elementary school times, in that window. Gifts for our teachers and maybe a few for parental coworkers and colleagues to have around the house, which those didn't last very long. There were a few different recipes on deck, and not on a deck. Who writes this stuff? A few different recipes on deck, whether pizzelles or cream puffs, the butterfly cookies. Those are always good. You put the batter on an iron. Usually they were butterflies, but they could have also been snowflake-like things. Actually, they kind of looked like pizzelles. You dip it in the oil. You dip it in the batter, and then you float it on some hot oil. Then you get this very light cookie, a little dusting of powdered sugar. You're good to go. Cream puffs, which are technically not cookies, but which were also in the mix. I mean, we were doing all kinds of stuff if my grandmother was involved. So like cream puffs and strudel and cheesecake and whatever else. Maybe some finger-looking almond cookies, maybe half dunked in some chocolate with some sprinkles on the chocolate, right? Are you getting hungry? Mexican wedding cookies, those are always good. And the cookies for this observation, Nancy's cookies, which are an unusual little thing that was mostly secret for a long time. So I'm not going to share it here. So let us say it's a sugar cookie that would remain soft. So they weren't crunchy sugar cookies, and they were, I believe they would be classified as sugar cookies by most measures. So there you go. So here's the deal. As we were making more of those sugar cookies, for example, we were keeping track of actual recipe yield, which varied a little bit. At some point, we got a specific kind of a melon scooper or a small, it could be an ice cream scooper. You know, it has a squeeze handle with a little gear and a little scraper inside the scoop. I can't remember what number scoop it is, but I have one to this day. Comes in real handy if you're making cookies because they're all the same size. We had a consistent cookie size with more predictable yield. So now we knew pretty much within 2 or 3 cookies how much yield we would get from a particular batch. Then we got a separate thermometer to monitor oven temperature. So it would be hanging inside the oven at the rack level. So we knew what the temperature was at the point where we would be cooking our cookies. And more importantly, cycle time to reach the set point temperature between cookie sheet rotations was something, once you figure that out, then now you have most of your workflow ready to go. You're probably picking up on this assembly line already. At some point, I took on a little challenge and made something like 500 cookies by myself. That's not a brag. It's just once you got it all figured out, you just turn the crank and cookies come out. It's a couple of recipe batches and 3 cookie sheets in rotation, if you're curious. But if you're even more curious, let me tell you. The first sheet goes in cold, of course. So you've turned on the oven, you're preheating it. You scoop out those little cookie balls, put them on the sheet. I think the sheet was, did it have butter on it or something? To prevent, well, that would help with the browning of the bottom of the cookies, but it would also help with getting the cookies off the sheets so they didn't stick. But a cold sheet, the oven is preheating. Get that first sheet loaded up. You could probably even load the second one. Preheated oven, you hit the temperature, the set point temperature. And then after that temperature comes down, when the oven door opens, hopefully it gets back up pretty quickly, but that's something to be aware of. If you open your oven door and the temperature drops down and stays down, that might be an integral controller problem. If you even have an integral controller in your PID control system for your oven. In the meantime, the cookies can't go on to a hot cookie sheet or they melt immediately and they start spreading and they get gooey and I don't think they turn out as well. So one sheet is in the oven. I mentioned 3 in the rotation. One sheet goes in the oven and is in the oven cooking. So it's reaching whatever, say 400. So the cookie sheet is at 400 degrees. One is cooling, having cookies just removed from it. And one is cooled enough to load with cookie scoops. So hot, cooling, and cool are the 3 sheets. When a sheet is removed, the cookies cool briefly, so you can take it out, leave it on the cooktop. There are cooling racks to the side of the cooktop, so you start spatulating the cookies after they've cooled a little bit. So if you don't wait and let them cool just a little bit, then when you go to spatulate them, they will sort of smush, and you won't be able to get it up off the cookie sheet nicely. So you give it a moment. Then they're removed to cooling racks to the side, right? Eventually the cooling racks will fill up. So hopefully by the time the cooling racks are full, the initial or the older cookies that have been sitting there for, I don't know, maybe 20 minutes or so, they're cool enough to put in a Tupperware, or if we're doing the cookies for the teachers, probably on some sort of presentation plates or something. So that's even more of a little side pipeline through the cooling rack and into a presentation or storage destination. So the cookies, once the sheet is cool, it gets loaded up with some slack. I mean, depending on fatigue or distraction or sampling of cookies, there may be a little delay in getting the cookies onto the cooled sheet destined for the oven. But I've just removed the hot hot sheet from the rack in the oven. So the thermometer's there. You can see the temperature drop a little bit. So there's going to be a minute or two to reach the set point, to reheat. And so during that time, there's a little bit of that slack to get the rest of the cookies ready to go. Once the temperature is set, you put them in the oven. I think it was 8 minutes. And we check the temperature against the separate thermometer so we know it's good. We're all set. The loaded rack goes in. The cooling sheet moves into the ready position to receive cookie dough once it's cooled off. And you really don't have to time or check the temperature. It would just always work out that as the sheet was coming out of the oven, the cooled rack was pretty much cool enough to put a new collection of uncooked cookie dough scooped on in little spheres, and then the process could continue. The loaded rack goes in, the cooling sheet moves to the ready position to receive cookie dough, and the hot sheet is moved to the cooling position, and it continues. 8 minutes cooking time with the time for temperature rise and settle was enough to keep the cookies cooking almost continuously. Not quite, but almost, with just one person. Fun fact, I didn't write this down, but fun fact, years later, what would that be, like, probably like 20 years later, maybe. My mom was cooking, or she did herself the first time, but Cookie Command, a little project to send cookies to troops in Iraq, was several people. I think the second year was several people in one location cooking cookies in multiple sort of demonstration vignette kitchens. So it was a kitchen or an appliance company showroom. So they had multiple functional kitchens for cooking presentations and to demonstrate so on. So, you could have probably 3 or 4 or 5 people per vignette. There were 3 or 4 vignettes. So you got a little crowd going and you could pump out some cookies. And then I think it was the third year, it was cookies in multiple vignettes at multiple showroom locations. And I don't recall the stats, but there were a lot of cookies flowing into that region of the world from Arizona. Crazy. It's a lot of cookies. Who doesn't like cookies, no matter where you are? So McDonald's, I had an opportunity to work in a McDonald's inside Metro Center Mall in Phoenix in the mid 80s. That was mall. That mall was a place to be. Metro Center was very popular back then. It has been demolished in recent years, not as popular. And if memory served, I worked there for a single holiday shopping season before and after, which was brutal. Metro Center was the place to go shopping. They had extended mall hours, which means McDonald's was open for those extended hours, probably even longer. And then I was always smart enough. I was always smart enough to do the closing shifts. I've talked about McDonald's before, so with more detail. But I will say I would always get my 40 hours plus every week. Even if I started out with 4 hours, I would just be sure I was there when the schedule came out. And then, hey, does anybody want to work for me? Yes, I'll take it. Why not? Yeah, the good old days. The mall itself was a madhouse. While I did come away with even less desire to consume or be near pickles, I didn't really like pickles before. Smelling of ketchup and coated with grease, I didn't like those either. It was actually a substantial learning experience, believe it or not. Yes, I think people in high school should work in fast food restaurants. There's a whole bunch of things that I'm not going to even mention here, but I think I probably did a little bit when I talked about this specifically in a previous episode. But yeah, personal interaction, being able to function in a workplace, interact with customers who don't want to interact with you, the list continues. Probably all of it will be replaced by AI and robotics. I know McDonald's has been on that kick lately. It's too bad. The Eloy will be what we deal with. Now, this was in the 80s, and the store was a co-op in a mall. So it was not on the leading edge with the latest kitchen equipment. Older timers, low cycle gas grills, no clamshells, so no speedy cook times, cooking both sides at the same time and whatnot. Old bun toasters that were kind of heavy and rickety. Everything was built to last, but not always for speed. Despite there being a training video seen, probably the first or second video you would see if you started working there. For the new recruits, I saw it. Make it fast, make it friendly. I don't know if they've upgraded it since then, probably. Sometimes this was made more difficult by the heavier, slower devices that we had to work with. So it was make it sort of fast and try to make it friendly. Where's my hamburger? I know, sir, you can only cook one side of the burger at a time here. We're not cool like that. The big thing to take home from a fast food job in high school, in my case, the lines are tuned. All the production lines through the kitchen of a fast food restaurant, even to the front of the house, cash registers and so on. They're all tuned, and things are made as simple as possible to enable a new employee to deliver on demand on a busy day as a team player. To be a part of the team, like, first, second day, you should be kind of getting the hang of it already. It's not difficult. The fun part was taking on a flash crowd out of nowhere with an understaffed kitchen and incoming regular and special orders. Being in the mall, this would happen without warning. There might be a crowd of 20 people that just randomly decides all at the same time, we should go to McDonald's and order a bunch of special orders. Anybody here like pickles? No? Let's go. And I'd be like, I don't either, but why all at the same time? Because when you have no pickle, you have to create new hamburgers, for example, or quarter pounders or cheese or whatever at McDonald's and not have pickles on them because the stock product included a pickle. And certainly no one would ever lift the pickle off a pre-made burger. No way. The fun part was, though, taking on that flash crowd, and that was a very educational experience. Offsetting some of the things, like offsetting them in time, so that the timers would be just enough out of phase to enable the walk around the prep table to grab the fish fillets while the burgers were just about to be hitting the turn light, so you can go back and flip those while the bun is steaming for the fish fillet and all that stuff. Once you got the rhythm, and you could kind of figure out which things took long enough so that you could walk around, like I said, or you can do the dressing of the buns, or you got to do the turn, or you're going to have to lay down some more patties on the grill and sear them in 20 seconds, all that stuff. You would once you had that rhythm, and you could align things with those offsets, phase offsets in time, you wouldn't need a whole entire kitchen full of people all the time. Knowing how long the wait between pulling finished 4-to-1s, that's quarter pounders, when the cooktop was back to the set point temperature, because it would have to heat up again if you cooked a bunch of big old quarter pounders. Not as bad with the 10-to-1s for the hamburgers and cheeseburgers, but you still had it. You would hear the gas come on, and it would be heating put the burgers down on a cold grill, they would all stick to the grill. So that's no good. So yeah, you kind of get a feel, you get the rhythm, but all these things, there were little subtle nuances like the burger sticking to the grill if it's not hot enough. So all this stuff would kind of be factored into a mental model of how things had to fit together in order to, because, once burgers are sticking to the grill, now you got to slow down, clean the grill off, make sure, it just becomes, and you can't really serve some of those burgers. So the good old days to be 16 again. All of it was a great way to learn the value of tuning a production line and becoming familiar with its subtleties. So once you understand your processes, the different stations of a production line, I think that's the usual parlance, then you understand why things are slow, why things have to be balanced a little better, where you can delay, where you can offset. So that comes in super handy. So that was actually a pretty educational item on my resume. And again, I think there's a lot of stuff you learn when you're working in a fast food environment with other young people, age peers. I highly recommend it. Supermac and lab practices. My first job on graduation from Harvey Mudd College was at Supermac Technologies, and I had the awesome task of benchmarking graphic accelerator cards on the old Nubus Macs. On first blush, this does not sound, it's not the most exciting thing by any means. It sounds pretty awful, actually. Though it was a marketing game to be played with Radius, their main competitor. Eventually, Radius would buy Supermac. Always trying to find 1, 2, maybe 3 operations faster on the Thunder 2 than on the Radius, whatever they were selling. Honestly, I didn't even look, but it was probably the Radius. It'd be funny if it was the Radius Ulna, like a forearm. Anyway, part of what we needed to do was to have defensible process and results. If you made a benchmark comparison in an ad and it turned out to be wildly wrong, then there would be at least a big stink about it. Maybe there'd be some legal action. And I can't remember if that ever took place. But, if you make claims about a competitor and they're completely wrong, that rubs people the wrong way. So advertising numbers that could not be reproduced was bad form at best. So there was a certain amount of leeway I was given to establish a stable lab-like environment. The laboratory sciences parts of my college education came in handy here. So reproducible meant using the same parts. Who took the DIMMs out of, or SIMs? They were memory SIMs back then. Who took the SIMs out of my, I needed them for that. I'm like, well, I need them back. That's my scientific setup. And my manager at the time actually supported that because he had a background in physics from Princeton, Berkeley, one of those. So he got it, which was convenient. So, you are paying attention to the details in your lab setup. I'm right there with you. I got it. So, but being able to reproduce your results and have a system in place. In addition, best practices for consuming the benchmark data, capturing multiple runs to reject noise and identify common mode errors if they popped up. So, why is this number consistently wrong as compared to previous versions of firmware and drivers and whatever else? Like, what's going on here? And you can track that down because you have a reproducible, oh no, we're using a different computer. That's why, okay, that's throw everything out the window. So keeping track of versions, how you consume the benchmark data and keep track of it and aggregate it over time and analyze it and so on. All totally useful. Granted, this was not a production line of physical building of things, but it was a workflow where the data was moving through it, right? The benchmarks were generating data, the inputs would be the firmware version and whatever other updates and system configurations, and outputs would be performance metrics and so on. So yeah, a different kind of workflow, a different kind of a production line. So some of the information was treated and the results were presented so that marketing information could be delivered for advertising. So here are the biggest deltas. We've improved here. They're winning there, so don't show that one, etc. So absolutely biasing the ads. I mean, that's how that works, but you have to pay attention to that stuff. That still happens today. You're not going to you're going to show your product in the best light possible without being too overboard in misrepresenting your competitors. Intel has gotten in trouble for some of this by using chillers to cool their newest CPUs when they're comparing them on a stage or something. So not everybody is so ethical. At the same time, we would hand off some of a little bit more detail, like the full set of benchmark data and comparative metrics and other whatever else we were doing. Quality metrics, right? Like, oh, why is this suddenly turning black on the screen? The video acceleration for that operation is not working. So every once in a while, because the benchmarking tools were measuring granular use of individual graphic acceleration routines rather than, a smattering of whatever. So you'd actually be testing a clip region with an XOR or whatever it was. So you would be able to see if there was a bug, a regression to a previous bug, etc. So completely understanding the reason for and the operation of this little production line came in handy, and it was also yet another skill to take advantage of later. We're going to talk about Palm, but I didn't want to go too much. I mean, I've already done my Silicon Valley thing, but these are specifically workflow-related stories. My Silicon Valley experiences are many, and I've talked about them in previous episodes. My 2 tours, this was during the second tour. So I had returned to Silicon Valley. So I left out most of the Supermac, went through several companies, moved to Phoenix, worked for, whatever. So Palm was an interesting learning experience with 2 wins, thanks to something as simple as paying attention to what I assembled as a little data production line for locating the cause of a critical hardware failure and understanding how the systems worked, or more when they were not working, and how to recognize that for the second win. So keeping it short, the first thing was the device failures we started seeing, which required, I'm going to mix tenses here because sometimes I'm in it and sometimes we're looking back at it. They required a root cause analysis and then a thing that I called the octopus that connected like the 22 phones I was able to steal from people. Like, I need your phone for this critical testing. Am I going to get it back? Probably not. And that was true. It ended up, it was not, ideally it would not have been destructive testing, but the problem we were trying to hunt down was why were phones dying, thus being destroyed by something. And it was a hardware problem with flash parts, in case you want to jump ahead. So 22 phones were connected to a single host computer over USB through USB hubs. To capture log data continuously for days. These phones would be running the same flash stress tests and capturing data to determine when they became corrupted and eventually failed. And then we would take the sequence that was, as the devices started failing, you could find those sequences that started to become, or appeared to be common between them, and then you could actually run the same sort of test to see, can we just isolate it down to the 10 or 15 things that happen in the right order to kill the device, which would happen. Well, let me be clear. The initial problem we had, the devices were failing because of what's called wear leveling not working. So as you were writing to the device, writing, the flash part is deleting, moving data around, rewriting it, doing block erases and so on. So there's something called wear leveling, where instead of rewriting the same block all the time, you shuffle them around a little bit so they all, over time, all the blocks have about the same number of erasures, because you can only, I can't remember which one it is for NAND and NOR and all that, but you can only clear a block probably to 1s and write 0s, or maybe vice versa. So you can write new data to a block as long as it's resetting or setting bits, I guess. But if you need to if you need to alter data in a block on your flash device that is not, and I may be totally remembering this wrong, but if I'm not mistaken, you have to copy that block into a new block. So you erase, or probably already erased, available block. You move the data to that block, and then you clear the old block, so then it's ready to go for some new data. Anyway, so there's wear leveling is going on all the time, automatically inside the part, except for the parts that we were using. So like half of our devices we had 2 vendors. We had 3. One of them had already failed before we even got here. So the second vendor, their devices were not wear leveling, so they would literally, a long time later, like months later, I saw what's called a micrograph. So they shave the chip down and they take a picture of it. And there was literally a burn mark because the wear leveling was writing to the same block all the time. And it was, I guess it was heating up, or it was burning out the fuses and whatnot. And so there was a visible wear on the part. So that was not going to be working. And the nice thing is we didn't ship phones that would eat themselves in like 6 months. But then I've totally gone off the rails here. So I put all this stuff together and I learned a ton about the precise boot process steps for the phone from power on to running because I was doing power measurement and some other stuff and some other automation and whatnot. So I was all about the phone booting up, what happens when the phone boots up, what happens when power is applied, what happens when you remove power, all that stuff. And then to failure, of course. So I was keeping track of all that with the octopus. Leaving this set. So once we identified, okay, it's the I don't want to put anybody on Front Street. So I'll just say it was one vendor that we knew was a problem. But I happened to have some other devices from the final vendor, and those were kind of the reference. It was like, well, we have some of these, we'll just make sure they work since we're running this. So as expected, the other vendor, the safe bet, they were all doing fine. So I pulled off the devices that were failing. Some other people took those and sent them to the memory vendor so they could do that teardown. And we basically said, okay, we don't have two vendors anymore. We are down to one. And you'll probably figure out who it is. But when we were launching the Palm Pre, Apple was going to be launching an iPhone, and they were using 10, was their order 10 times or 100 times? It might have been 100 times as many. They were ordering 100 times as many parts. Just a massively huge volume of parts. So we're like, now the only parts that we can use in our design this late in the game come from the same company that is supplying Apple with an order 100 times as large as ours, because the iPhone was pretty popular. So there was a lot riding on this. So I left those parts running on my Octopus. Probably a day or two later, I went in there and I noticed that one of the devices had failed. I had the screens turn red if they were failed. So I found a red screen. I was like, uh-oh. So I went out. I literally had a little lab space in a meeting room. So I had that set up as my little lab. I opened the door to go tell someone, Houston, we have a problem kind of stuff. And the vice president of engineering, director of engineering, was walking by me at the time, like literally almost bumped into me. I held up a phone. I said, this is a other vendor flash part phone. And I walked in today and it failed. And he just looked at me like, no. He didn't say it. He just looked like that. So that forced even more emergency meetings. So as it happens, we had that Octopus ready to go. And so we found this second failure mode and the only vendor we were able to work with. So I think it was 2 or possibly 3 people got on a plane and flew to where they were making those parts. And I had so it was kind of like Apollo 13, hence the Houston, we have a problem. So they were in this other country with, sitting in the lab with their engineers. And I had this thing to reproduce on our devices. So in situ, in circuit even. So I could reproduce and we could try new things and try out capturing more data and whatnot. And we started doing some risk analysis on whether well, anyway, so the long story short, because we had this working line to run tests and capture data on as many devices as we could find, we were able to come up with significant data to make the case for whether we should apply the fixes that they ended up finding in the other country. They said, oh, okay, we've identified the problem. Here's a fix. You can do this way or that way. And so then we could measure which one. So we had half the devices doing one way, other half doing the other, etc. But here was the rub. Because we found this problem that had not been found prior when our people were in the other country helping them out, they were, well, I don't know if they had that conversation, but clearly the collaboration went well because then our order was guaranteed. Because essentially this company did not ship a bunch of products that were going to fail to Apple. That would have been a bad thing. So because we were able to help them out, they helped us out. And that's why the Palm Pre is as successful as it is today. I got a little bonus for my troubles. So that was nice. Palm at the time was going through financial struggles. So, and of course it didn't last much longer after the Pixie. I don't even know if the Pixie really shipped. That was the second phone of the Palm OS days. Now LG, I think, is using the Web OS version, which is similar. They modified it to be their TV operating system for LG smart TVs. But anyway, so I got a little bonus out of it. That was not common, so that was kind of nice, I guess. A very tiny gesture of gratitude that was followed immediately after with my horrible manager being a jerk. But anyway, that's a separate thing. But the second win came from the devices when they were turning on mid-flight, or they were turning on at some point. We didn't know, but they were turning on while they were being transported to the U.S. So the reason was unknown. They were on their way to the U.S. from China, from somewhere in Guangdong, probably closer to Shenzhen. I don't remember who was making them. I don't know if it was Foxlink or Foxconn or somebody. Don't remember. Being as familiar as I was with how the device works at a low level from power on, I was joined by the person who wrote the boot code to examine all the information we had to learn why a couple of devices would seemingly just turn on for no reason, well, that we knew of yet, leaving devices with dead batteries on the shelves. So that's never a good thing. Nowadays, people want their phone to be charged and ready to go. The phone was fine. But just the battery was dead. It's just a bad user experience, but not damaged, just dead battery. Happens to me all the time. Probably happens to you frequently. It's the way it goes. It took about a day or two, but it was fairly easy since the mobile phones, they're full of computers, even at that point, many years ago. So there was logging of things when the power. During assembly, the phone would have a battery in it. They called it the bench battery, I think. It was a battery they would just move it between phones. So as they built one phone, the bench battery would be in the phone. It would reach the final quality check, and they would run it. Everything was fine. Then they would take out. No, did they run it? Well, they would put in the shipping battery. That's the battery that would leave in the package to go to the customer. And then they may have run some testing at that point. But the phone is logging the stuff when it's going through this because it's a little Linux computer inside. So we had tons of data to look at. So you could see, okay, the phone that's dead, it turned on here. There's a cell site in the factory so they can test connectivity, Wi-Fi, and all that stuff. So you could see all this stuff in the logs that were being stored. And then you could see when it would be rebooted because the battery was removed and the new shipping battery was inserted. And then you could see, you could literally see how one of the phones we had turned on when it was on the loading dock. So you can measure from the time somebody put the battery in and it powered on when they did that. And then they would shut it off by holding down the power button, put it in the package, seal it up, run it down the rest of the line put it in a box and put boxes on a pallet. The pallet will be moved out onto the loading dock to be put in a truck to be brought to, airplane, probably. Eventually they would probably be on a ship, but this was a short turnaround. So on a plane, the most expensive way, of course, to ship things, and slow boats from China. That's where that comes from. So we were able to determine when the phone had turned on, and then you just go, back in time, okay, what's happening at that time? Okay, the phones are shipped in the boxes upside down. The power button's on the top of the phone. Probably when you drop the pallet on the loading dock, ready to go into the truck, or maybe it does this inside the truck. The phones are going to bounce. If you do a little Bessel function, you can figure the math of a drum head, right? So when you strike the head of a drum, the different parts of the drum head move in different directions and different amplitudes. Oops, I just bumped into the microphone there. So we didn't go this far, but you could probably figure out where the maximal impulse from the dropping of it's not like they were throwing it, but there's a little force and it goes up through the packaging and would bounce some of the phones and turn them on. So they had a pretty good idea that's what was happening. So they redesigned the packaging, which would take longer, of course, but so the packaging had a little dimple around where the power button was, and there was a software patch so that you had to hold down the button before the phone would turn on. And I don't know if you've noticed, but that's become the standard, right? So if you want to turn your phone on, you got to hold the button in for 4 seconds. No more instant on. So that way you avoid accidentally turning on your phone. Good times. But that was another case where completely understanding how the device works, the different steps in the production line, being able to get that data, understand the workflow of getting the phone built, tested, packaged out to a vehicle. And then I think occasionally you would get one that would come on, where was it? I guess they would come on once they landed. That was also a possibility. So you could basically figure it out because the phone had GPS in it, but you could also depending on when it came on, or even better, when it died. So you could determine when it died and then go back in time if you didn't have like a GPS signal. So you could figure out where it came on based on the transit routes for the shipping and all that stuff. Totally interesting. So that's one of the, it's like a puzzle. You figure out what's going on. So if they bounced just right, they would power on. And that was the name of that game. So we had the root cause, we had a fix. We had 2 fixes actually that they implemented. And I didn't get a bonus, but we all get to have long press power on our mobile devices. So that's that. That's something. I would go on to Jawbone after that. Jawbone, makers of Bluetooth headsets. That was mostly, I think when we were working there, that was like 93% of their revenue or something crazy. So they had some not smart speakers, but they had speaker products, the Jambox, which was pretty cool, to be honest. But headsets, Bluetooth headsets, they were the name of the game. So this was another interesting work experience. People at Palm jumped over to Jawbone. I had already left Palm. So when Palm sort of imploded a little bit, some of those people jumped over to Jawbone, which was like 2 blocks away. This is Silicon Valley, right? So 2 blocks away, there's a whole nother company that you could just move a workforce to. Like, do you want to hire 40 people? No, I think it was more like 2, 3, 4, 5, 6, 7, 8. I'm going to say like a dozen. It wasn't 2 people. It was not 20, but I think it was a dozen. So people at Palm jumped over there. So I got dragged along eventually. And the thinking was they wanted to set up a second manufacturing site in Mexico as an alternative to the one at Foxlink in Guangdong, China. They were definitely in Guangdong. They were a little bit outside of Shenzhen. Shenzhen is in Guangdong, if memory serves. That is where everything is made, as it turns out. You probably knew this. So I commenced learning how the assembly line worked, with some of the important parts replicated in a lab space in the Sunnyvale offices where we were based, very near where Palm was. I ended up reproducing the software components of the quality control measurements and process, including the calibration of the devices. If you had any inkling what a Jawbone, used to be called the Aleph, but then it was Jawbone, Jawbone Bluetooth headsets, they had a little extra, it was literally a microphone that would touch your face. And the idea was that little microphone would pick up when your actual jawbone was moving, hence the name. So it would know when you were speaking, and when noise it was picking up was not you speaking, and it would adjust the noise cancellation accordingly. So pretty neat. A lot of patents on that stuff. So I learned how they did the calibration. I learned they were using a lot of MATLAB. So the MATLAB is famous for their DSP stuff. I built some speakers in college using MATLAB, designed the cabinets and the crossovers. So I commenced learning how the assembly line worked. We had the important parts, the calibration tube, which was an anechoic, so echo canceling tube. You would clamp the headset into it, and then it would play some test tones, and it would do some constant derivations for the actual makeup of the physical body of the headset and the property, the driver. What was it? The microphone. Yeah, the microphone properties, some values for the microphone that it would pick up in the calibration tube. Then we had this other thing. You would clamp it in and put it in this enclosure to do some silent testing. And there was one other thing. Anyway, those are the important parts. That's where the math and the code was running, and you had to have good, clean sound and not a lot of noise going on elsewhere and so on. So we had all that going. So what I did first, I said, everything you're doing, we can just use Matplotlib and scikit Python tools. So I implemented everything that they were doing for calibration and interfacing with the device and running these quality control tests after the calibration. I implemented them all in Python, driving an external, I think it was an M Audio sound card, drive the actual tops. Is it tops? Torso something? I think it's tops. If you've ever seen these, it looks like the upper body of a human, and then it has a microphone in each ear, and then a speaker in the mouth, and you can actually do like realistic audio or realistic audio measurements based on, actual deflection of audio and whatnot by the shape of the head and everything. So those are very high quality reference microphones and speakers. So we had those in our test setup. So we would drive those with a reasonably high quality USB sound card, and there were test tones and there were data measurements and there was all kinds of stuff going on. And then we would present and measure the results, and then the device would get a pass or a fail, and there would be a report available per device and so on. It was pretty neat, actually. So I made that all with free tools so that if we moved the line to Mexico, or if we had a duplicate line, there would be no need for a seat license for MATLAB per production line, or for however many stations there were. So yeah, we could just implement everything with free software tools. We were good to go. In fact, I was sitting next to the lead DSP system architect, Steve what was his name? It was Steve something, Italian last name. He was like, "What is this? It looks like what we use, but not quite." I said, "Oh, I just rewrote everything in this free tool." There wasn't a lot of, the math part was pretty easy. It was actually driving the audio cards and some of the other data capture stuff that was tricky, but the MATLAB stuff, almost directly, piece of cake. And he was like, you did all this with free software? You just did it?" And I said, "Yeah." So he was, that was pretty cool. He was pretty impressed, but pretty smart guy. He would die of a heart attack not long after that, about a year or two later. That's not the good part. So since I was reproducing a production line in our lab, I was able to identify some potential issues with the way they were misusing some of the workflow items for calibration tests by reproducing their bad data. So once I was seeing what they were sending us for their test results, I was able to reproduce those by moving, audio does strange things depending on how close or far away you are from different parts of a room, however small that room is. So I mentioned you would put the device in a little clamped speaker test rig, and then they would close this little sound. It was actually a Faraday cage and not intended to be truly soundproof, but it worked well enough. But if you moved the test rig around inside the enclosure, you would get different results because of reflections and so on. So once we figured that out, we were able to give better instructions to them. So there was a whole bunch of stuff that came out of this exercise to understand and be able to reproduce with high fidelity the production line to get the same product outputs no matter where in the world they were being built. I could also see some odd behaviors in time-stamped test data. I made this 3D spinning cube thing that showed different test failure modes per production line, per shift, like time of day. So production line, time of day, and then failure mode. So like these devices are showing microphone failures, these are speaker, these are calibrated incorrectly, etc. And I started noticing that the data was time-stamped for 24 hours a day, 7 days a week. And we were paying for 2 10-hour shifts, 6 days a week. So if you know anything about how the black market works, you can figure that out. They had a little side door. Hey, you want a couple of Bluetooth headsets? Cheap. The other fun one, with all of our experiments in our local lab replica, when we were encountering some weird behavior on the new line, they added a third line because we were adding another product and so on. So we had 2 production lines. They were pretty much identical. They were physically next to each other. So we had this third line, which was not located in the same physical area of the Foxlink facility. It was literally like by the windows, I guess you could say. So it was not like intermingled with the other production lines from other companies making stuff. It was way over at the edge of the building. I don't know if it was like 1,000,000 feet away or 10, but it was not nearby our other 2 production lines. So it was just in a physically different part of the building. And we started looking at that we were starting to get failures for some, all the stuff coming out of that production line is broken. All the data is wrong. It's not calibrating correctly. What's going on? So I think there was a couple days in and they were like, this is not going to work. What's going on? So we looked at the data that we were getting from the QC, quality control, calibration testing, and so on. We started looking at what we were seeing from the line from what we were seeing in our production line in our lab. So the copy, right? The mini, and both myself and this guy, Camden Murphy, I don't even know if he's still around. He was a super nice guy. He knew the products backwards, up, down, left, right, everything. He was those products. So we were looking at this, and I said, did we see something like this with the sound card when we were picking up some noise? So we started trying to simulate and filter power line noise going into the external USB devices. External sound cards, by the way, they're going to tend to be a little bit less noisy because you're not inside a computer enclosure with its power supply and fans going and everything. So this is a completely external power. I bumped in the microphone again, sorry. Completely external power, hopefully clean power. But so I think I may have done this like in the evening because I used to like, I guess it was email. I can't remember if it was email or some other messaging thing. So we had 2 employees at the Foxlink factory, and there was a guy, his name was Chemo. I think the other one was Sunjin and Chemo. Sounds about close anyway. So one day I said, hey, Chemo, if you go over that production line, the new one, is there like a air conditioner or some like a refrigerator? Is there something with a motor? And he went over and he came back, or whenever he responded, he said, yeah, there's an air conditioner hanging from the ceiling. And it's on because during the day it comes on because it's hot. So if you don't know anything about air conditioners, they're an inductive load. They put noise on a power line, or they can. So because the air conditioner was so close, the power that was going to the USB sound cards was coming from the same loop, same circuit. So yeah, they were picking up the inductive noise coming from the air conditioner on the power lines. So that was throwing off all of the audio, both, generation and capture, microphones or speakers and microphones. So calibration was wrong, QC was wrong. But if the air conditioner was turned off, it would be okay. So yes, of course, we were seeing some were okay, some were not. It was a big mess. So that came down to like a little bit of understanding of how electronics and how physics works, some practical experience with how the lines are set up, what they were seeing based on some things we had seen in previous weeks with some of our experiments. So yeah, it was the ceiling mounted air conditioner. Knowing the line made it a small matter at the end of the day. So that was a couple of days solved. Pretty good. So where did all this come from? Why? There's not magic, and I'm not bragging, but it's like I do enjoy and I find it interesting, and I've had a couple of successes. I don't know if I don't really have any like failure stories, but I think because when you get a little challenge like this, you're always like, ooh, this is new, a little puzzle to solve. There were probably more of these, like the entire mobile vending industry coupled with local economies, which I've become interested over the years. Then maybe cohort discovery and collaboration over time is related to our nonprofit civic volunteer organization, collaborating with other organizations around the country, possibly around the world. So the discovery process especially is tricky. Aside from the cookie stuff, I had noticed over the years that I tended to sort of see workflow possibilities. I mean, in addition to the cookie stuff, I guess, even in simple things like a couple of people working together to stuff envelopes for a mass mailing, right? You start to notice like, oh, maybe you should do the folding of and then you should do the licking and I'll do so you start to see that some people are more dexterous or more they're handling they're better at folding a triple fold sheet of paper to go into the envelope, whatever it was. You can start to see like, oh, and that's called load balancing. So you just look at which steps are taking longer, and if you reorder them or you double up on, hey, can we have one extra person doing the folding? Then you balance out then things move along nice and smoothly and you're all good. Then you don't have one person sitting there waiting, stuff like that. One class we took in college, second year for engineers at Harvey Mudd, was basically a first course. It was like, I think it was E94. I think it was E94. The first course in chemical engineering, which leaned heavily into chemical processes for batch and continuous processing stream types. Think of a batch as a reactor of some kind, like a mixing bowl with ingredients in it, while stream has inflows, outflows, products, accumulation, and maybe more stuff going on. You can put these together. You can have, like, you could look at a nuclear reactor as the batch process going on inside the reactor, and then the water cooling and turning the turbines and stuff. Those are streams, continuous flow of superheated water and turning into steam, and then turning a turbine and then cooling and going back, the whole loop. The two water flows, one goes in the reactor, one stays out, et cetera, et cetera. So there's different ways of assembling all these pieces It's important to know how they work and how they work together and what goes wrong when they don't work. How you can tell. And yeah, so these are probably happening pretty often. I always found that I could sort of see how the processes would balance at steady state. Being, knowing the transients that start up and shut down are also important, and how it responds to errors and changes in parameters and so on. But, once a thing is working, you can predict and measure and check inflows, outflows, all that stuff, which I would then prove with the actual homework with the maths. So you would balance all these equations to make sure you, at steady state, you have inflows matching. If you have more going in than coming out, you have to wonder if you're going to break everything when you fill it up, right? Ooh, how come none of the water's coming out? Uh-oh. I think in the end, this is why I like system design and architecture over something like web programming. Web programming is fine, but I've never really been, dealing with people, there's more to worry about. Designing systems requires pretty much the same sort of consideration as chemical engineering, with what comes in, what goes out, what gets stored in a database or in a file, what the actual product of the system is. So like delivering a web page or sending out an email or something. So the inflows and outflows are between the different blocks of functionality, and the product might be an email to send or a web page or a notification or whatever, a financial transaction. So yeah, this is kind of interesting, and it kind of fits into that same model. And I've just described in these examples similar models, right? They're all kind of the same when you get right down to it. It is the deep dive into this functionality, the way the different parts work, that makes it all really interesting to me anyway. When you understand your systems and how things fit together and what the failure modes are and whatnot, I'm not going to say it's always easy, but it can be easier to solve problems. And so it's like solving puzzles. And historically, I've tended to be pretty good at that because I'm actually interested in doing that. So that's how that works. Ultimately, the systems thinking and application of processes and workflows to how we can work with, maybe even improve systems, is what I have been leaning toward more and more in recent years. How things fit together, how they flow together, what happens when they stop doing that. You have probably heard me speak of the entrepreneurial innovation ecosystem of the Greater Vegas area at some points. Definitely applying that there. And if you have not heard that, you should probably head over to the Cafe Genius Impresario's audio program and listen to any of those 150-ish episodes if you would like to know more. Where would you find that link? Well, on buymeacoffee.com/Dan Hugo, of course, Cafe Genius Impresarios, about our entrepreneurial innovation ecosystem. So if you consider like economics and production, like the mechanisms of making things and then selling them, those are like different systems, but they're definitely connected. So like making products that work, and then making products that will sell, and so you have enough of them, and that you have an alternate vendor list or approved vendor list. So if one vendor goes out of business, or their parts start eating themselves after 6 months, or intensive testing, you have another one to fall back on. Like all these things fit together. So economics, ecosystem, assessment, and development. I don't think you can build an ecosystem. That's for another time. But you can think ecosystem like desert or rainforest. Well, can I just convert a desert to a rainforest? You can, but not today. But anyway, all this stuff kind of fits together, and those are a couple of the high points. But yeah, if you follow the work that we are trying to accomplish with Cafe Genius, and if you look at some of our innovation projects, if you look at hopefully it will unfold nicely, the Smarter Smart City challenge that we're putting together to last the whole year. These are a lot of systems, moving parts that fit together, and they're moving along through a timeline. So it's kind of like a continuous flow in time and interactions with people and so on. So yeah, it's a little bit of chaos, but that's how I got here. And that's going to end the story. You can hear my congestion still. It's the weather's been whack. It was raining last night. It's sunnier right now. It's very humid. My air conditioner came on the other day. It's supposed to be winter. I had it set to 79 and it came on. Who knew? It has been cold. I have not needed any sort of blanket or anything for the last month. So the weather is nuts. That's all I can say. The economy in Vegas, that's a different story for another time also. All right, I'm going to let it go. We're over an hour, but not by much. Thanks for listening as always. Catch you later. Take care.